Hello, my name is Harsha Ratnavira. I'm a professor at the Norwegian University of Life Sciences in Norway, uh, teaching in water and wastewater engineering. So today's lecture will be on centralized wastewater treatment in cold climates. So generally we teach about engineering and technological solutions for wastewater management in general, but there are many countries have temperature differences throughout the year. It could be 10 degrees or even 30, 40 degrees of difference. So when it comes to the colder climate, so we have to plan our treatment plants both in the design and building and also operation times. So this lecture is about some of the aspects that we have to think about when designing and building and running our plants. So cold areas, it's not only the temperature affects the way that we run treatment plants or manage our wastewater, but there are a number of other factors. Population density is one of that. So if you look at this slide, you can see how the population density varies throughout Europe, and the light yellow color means that the lowest density, and the up north the density could be as low as below 1% per square kilometer. So this also has some impacts on the way that we plan our wastewater treatment, because with such a low density, that means that people live, so there is a big distance between houses and communities, which means that to collect wastewater the same way as we do it in our urban center will be quite costly, because then you have to build sewer lines, and not only that, we also have to use quite a lot of energy to transport water and wastewater. So this is one of the things that we have to think about, and not always centralized wastewater treatment plants will suitable for all cold climate areas. Then this picture shows how the type of treatment varies between Norwegian counties. And if you look at the bottom three, these are the northernmost counties of Norway, and the colors, the smallest, the blue one shows that the percentage of treatment plants, or the percentage of wastewater which is treated secondary or higher levels, where you remove BOD and nitrogen and phosphorus. The red part is the mechanical treatment, and you can see that it is between, let's say, like 5 to 25% of the wastewater. And then we have the direct discharge, that means without any treatment. It could be anything between 20 to 60%. And the green ones are the small treatment plants. It could be septic tanks or very small other types of treatment plants. So compared with the country, and if you look at the upper part of this figure, that's the area surrounding Oslo and the southeast of Norway, as well as the other bigger cities that we have a very high level of wastewater treatment. The European Union requires that wastewater to be treated if it covers agglomerations of 2,000 people or more. And in many cases, in the northern areas, we don't have that type of agglomeration. Another specialty of Norwegian treatment plants are that most of our treatment plants, both when it comes to the drinking water and wastewater, they are covered. Either they are inside buildings or they are built inside rocks. So there are several advantages with that. One of the advantages is that then you can avoid snow into your treatment plant basins, and by that you are avoiding dilution of your wastewater, and also reducing the temperature of wastewater when the snow starts melting. So this figure shows the snow coverage during the year, and the bottom graph shows the lagoon temperature. So when the lagoon temperature goes down, the microbial activities are reducing, so the treatment efficiency is also reducing. So here are some pictures how the Norwegian treatment plants are. The two corner figures, one is inside, it looks like a house. The whole treatment plant is inside, and the other picture, it shows the treatment plant, a big treatment plant inside the rock. So inside the rock, the air temperature will usually, it doesn't go below +5 degrees. Even the outside temperature could be -30. So then your wastewater will also have a higher temperature than outside. Generally speaking, the northern areas have lower temperatures, as it's shown from this figure. The temperatures during the winter could go a lot below -0 degrees, and at those temperatures you might also expect a slowdown of all wastewater treatment processes. We all have heard about the climate change impact. One of the impacts is air temperature is increasing. But this increase of temperature contributes to the reduction of the wastewater temperature. It is a paradox, but it is also a fact. The reason is that when the air temperature is increasing, the number of days where the air temperature is shifting between plus and minus degrees around 0 is increasing, which means that we will have more days where the snow is melting. So when the snow melts, it goes to the wastewater pipes and then subsequently the wastewater treatment plant. By that way, the wastewater temperature is reducing when the air temperature is increasing. The cold temperature itself is not the reason for lower temperatures in our sewers. I would say it's mostly the leakages from one side. From the other side, the combined sewers are the problem. Combined sewer means that sewer pipes where both wastewater and rainwater are transported together. So earlier days we built these combined sewers, but now newer systems we have separate pipes, one pipe for rainwater and one pipe for wastewater. But still more than 50% of the wastewater pipes in most places in Europe, they are combined sewers. So this figure shows that if you had a separate pipe, the blue line shows that generally wastewater temperature, even in Norway, even in northern Norway, it will be between 11 degrees to 14-15 degrees. But if you had a combined system where the rainwater is mixed with wastewater, the sewage wastewater, the wastewater temperature which coming to the treatment plant could be +6-7 degrees, and as you can see from the figure, it could easily be 3-4 degrees lower than the separate systems. So this is why we need to try to have separate systems to solve these issues. Then coming back to the treatment technological concept which we are using. So we have mainly 3 systems: mechanical treatment processes, biological processes, and chemical processes. And in most cases, we do not have single unit processes today because of the requirements to remove not only one type of pollutants but several of them. So therefore, in many cases, we have a combination of mechanical, chemical, and biological processes. And here is an example of how these 3 processes are combined. Each process, each technological scheme or the flow sheets, they start with a mechanical treatment with a sieve and grit removal and separation of particles. And then we have the biological process and chemical process. The top one is where the chemical and biological processes are combined, which means that you add chemicals directly into the biological stage, activated sludge plant or the basin, Then we have the pre-precipitation solution. That means we first have chemical precipitation, and after that wastewater, which are chemically treated, goes to the biological process. And the third one is first we have biology and then the chemical processes. So each of these processes have their advantages and disadvantages. So when you are designing a treatment plant, you need to choose carefully which one is the most suitable one. So mechanical processes, chemical process, and biological process all are impacted by lower temperatures, and their impact varies. And one of the main things that we can avoid falling temperature too much is to have separate sewer systems. And then the other option is to select processes that can stand better variations of temperature. Chemical coagulation is quite widely used in Norway and Scandinavia. In fact, 70% of our wastewater is treated either chemically or chemical biologically, which means chemical coagulation is an important process. And during the colder temperatures, the floc formation slows down, which means the flocs, which are otherwise built to larger flocs and stronger and more compact, stronger ones, will not happen in colder temperatures. The flocs will be smaller and fluffy, which means it will take longer time to sedimentate or separate them. So in order to achieve the same treatment efficiency, either you have to increase the sedimentation tank's capacity, or you can also increase the chemical dosage, so thereby you are increasing the floc growth rate and floc characteristics. This figure shows that how the flocs look like in two different temperatures, 5 degrees and 20 degrees. And at 5 degrees plus 5 degrees, the flocs looks much smaller, and while 20 degrees they are larger, which means that it's easier to sedimentate. Biological processes are quite heavily influenced by the lower temperatures because they are living organisms, and these microorganisms, they are heavily dependent on the temperature. So this figure shows some of the experimental results of the nitrification process, and if we say the nitrification rate or the process velocity is 100% at 20 degrees, and when it reduced down to 10 degrees of Celsius, the velocity will reduce by 50%. So in general, we say a 10 degrees reduction of temperature will lead to 50% reduction of the nitrification rate. So if we want to have the same type of treatment efficiency during winter as summer, then we need to build our nitrification facilities much bigger, maybe even twice as bigger. So it's important to remember these dimensioning criteria. To conclude, that we can say that climate change results in challenges with the volumes of and wastewater temperatures. Volumes because we get more wastewater to our treatment plants due to more often and more frequent and heavier rains, and wastewater temperature is also going down because we have snow melting and the mixing of rainwater with lower temperatures in wastewater. So the main challenge in wastewater treatment in cold climate is not the cold climate, cold temperature itself per se, but the sewer collection systems which we have today. So most of our sewer collection systems, they are combined sewers, which means that we mixed our rainwater with wastewater, so thereby we are reducing the temperature of our wastewater. Many Norwegian treatment plants, they have started to use fine mesh sieves, which functions quite well also during the winter period, so thereby you are removing a good part of pollutants, most of the particulate matter, before they enter the biological and chemical processes. Therefore, we can have a better control of biological and chemical processes. In biological processes, as you know, there are two main processes: the attached growth and suspended growth processes. Suspended growth processes, they are much more compact, and the most popular one, which was initiated from Norway, is the MBBR process, the moving bed biological reactor, biofilm biological reactor, and they are much more compact, and they can also tolerate much better lower temperatures. So if the nitrogen has to be removed, then we are looking at the combination of mechanical, chemical and biological processes, and then you have to have a better control of the process so that they can function equally well during the winter as in summer. That's all. Thank you.